How do we do water management? We have advanced irrigation control equipment capable of controlling a large number of hardwired valves, as well as remote valves via radio communication. Smart Garden allows you to control these valves manually or from an irrigation program. In addition to the creation of irrigation schedules in a simple and intuitive way, the schedules are weekly and have up to 3 daily shifts that can be activated manually or automatically. The irrigation equipment is able to work offline, which ensures the irrigation of the garden even if communications go down. Each valve has its own independent irrigation configuration and can be configured by variables provided by weather stations. To offer better irrigation management, Odins has different models of data loggers, through which the platform can receive information on variables collected by meters and sensors, soil moisture, conductivity, and temperature, etc. And how do we do it? Only 2 probes installed in a grass meadow are detached from the ground, one in the sun and the other in the shade, obtaining the average of both equipment for greater accuracy in a reliable way and with a lower cost in sensorization. All the information collected by the sensors connected to these data loggers can be visualized in advanced graphs, which we can create with our Smart Garden platform. These graphs can also be generated from data collected by other devices. Smart Garden allows you to use physical weather stations, installed in the garden, or virtual weather stations, through web services. In addition to the usual variables offered by the weather stations, the platform has a service that calculates the value of evapotranspiration as another variable. Likewise, the platform has an AI algorithm that, based on the value of evapotranspiration and other variables, estimates the irrigation needs of the gardens to adjust the irrigation time, reducing or extending it. In the following example, we can see the correction of the irrigation of a valve that initially was 60 minutes and has been reduced to 56 minutes and 24 seconds with the adjustment in the middle of August. In other seasons of the year, irrigation reductions of more than 30% are achieved. The platform has a rules management service to act on the schedule based on the meteorological data or variables collected by the data loggers, allowing actions such as stopping, pausing, resuming, or adjusting the current schedule. For example, starting irrigation automatically if the system detects that soil moisture has dropped below a certain level. Smart Garden allows you to define the area of the garden through its enclosure management service, through the web system of the virtual cadastre office, or by easily drawing the perimeter of your garden. As we can see in this example, where we define the enclosure of the botanical garden of the Malecon de Murcia. Once we have created our enclosure, we can associate irrigation controllers, and users with it, as well as define a name and incorporate a descriptive text. In this way, we will always have an intuitive and detailed visual presentation of each enclosure. In some cases, external analyses are carried out in certified laboratories to find out the composition of the soil, water, or plants. The data from these analyses are usually in paper or digital format, but they are not exploited. The enclosure management service allows you to fill in forms with date and description so that Smart Garden can make a future exploitation of them. For us, external analysis is just another probe. Through the European Space Agency's Sentinel's multispectrum satellite imagery, we have data on the Earth's surface and vegetation. These cameras have a resolution of 10 meters, so each pixel covers an area of 10 by 10 meters. The acquisition of images is 5 days, so we will have updated information with that periodicity. We also have a filter to remove images in which a high level of cloudiness is detected. The platform automatically downloads the data and images corresponding to the area of our garden and represents them graphically for a possible visual study of the different indexes. For example, leaf stress, productivity prediction, vegetation greenness, soil calcination by fires, plant water stress, etc. In gardens, we work specifically with NDVI indicators, which shows the quality, quantity, and development of the vegetation. Our algorithm analyzes the values and reports anomalies if a reduction in the index is detected. We can't determine what's going on, but we can warn you that there's a possible incident. And NDWI, which measures water content in the field. Thanks to the information obtained with this index and making use of the data from a few installed humidity sensors, we are able to make an estimate of the entire plot, detecting areas where we may have a problem with irrigation. In order for green areas to help this climate well-being, we monitor the air quality, water quality, and noise levels of the area, all of which are interconnected with the meteorological data to ensure the reliability of the data. It is essential that we ensure that the air quality in green areas is within the appropriate environmental parameters, and we do this by measuring from suspended particles to all harmful gases that can be harmful to health. Equally important is the control of the water quality of ornamental fountains and ponds, so the control of chlorine pH and turbidity levels are essential to prevent it from being a focus of infection by bacteria, viruses, or parasites. We also consider acoustic monitoring to be fundamental, since gardens cannot be conceived as an environmental refuge without proper control of noise levels. It is important to have objective indicators that allow managers to execute planning aimed at mitigating noise pollution in green areas. In the same way, we are developing systems to control the light pollution generated by the cities to ensure future generations a better quality vision of the night sky in a sustainable environment. In order that the waste management of our gardens do not interfere in the environmental refuge that we want to ensure, Odense has the monitoring services of garbage containers and waste garbage cans. We measure the filling percentage, position, and temperature. With this data and through algorithms we can estimate the quantity and cost of the waste generated, being also able to monitor the periodicity of collection and the incidents that could have the container as fire or overturning. As for the bins, they are identified using QR codes and geolocation. With a very simple application, the staff in charge records the collections, which allows the process to be controlled and optimized. Finally, people counting provides information on the transit of citizens in green areas. By making use of our software solution based on video analytics, we are able to determine with an accuracy of over 95% the number of people who are in a particular area. From Smart Garden, we can make use of that data to generate occupancy graphs, show real-time values, and generate reports of traffic levels by hour, day, and month. Odense philosophy focuses on the use of technologies based on standard and open protocols, which allows us to integrate our solution with other global smart city platforms, thus favoring the growth of the ecosystem and the establishment of disruptive technologies, but with solid foundations on which to develop the infrastructures of smart cities, opening the door to innovation and development beyond the limitations imposed by proprietary solutions. The citizen must be the main axis on which all the actions that serve to make parks and gardens a climatic and environmental refuge revolve. Odense. Open Data Intelligence Solutions.